We think of black holes as cosmic vacuum cleaners, monsters sitting in the dark, pulling everything into an inescapable maw. But that is the first illusion we need to shatter. If you replaced our sun right now with a black hole of the exact same mass, Earth would not be sucked in. Our orbit would remain perfectly stable. The planet would freeze in the sudden, absolute darkness. Yes, but gravitationally, nothing would change. The real danger is not a black hole sitting still. The real danger is a black hole moving. What would actually happen if a rogue black hole did not just sit at the center of a galaxy, but passed directly through our solar system? The answer depends entirely on what kind of monster is visiting. Black holes come in different sizes, from microscopic relics of the Big Bang to stellar mass corpses, all the way up to supermassive giants. For decades, we thought our solar neighborhood was relatively clear of them. But recent data from the Gaia mission and Hubble observations has forced us to update our maps. Astronomers have found rogue, isolated stellar mass black holes drifting through our galaxy, some surprisingly close to home. Objects like Gaia BH1, Gaia BH2, and Gaia BH3, along with an isolated rogue black hole discovered about 5,000 light-years away, prove these invisible gravity wells are far more common than we ever believed. They are traveling at speeds of dozens to hundreds of kilometers per second. Statistically, the chance of a stellar mass black hole coming within 100 astronomical units of Earth is exceptionally rare, perhaps once every 100 billion years. But rare is not the same as impossible. If a rogue black hole entered our solar system on a hyperbolic trajectory, it would not act like a vacuum. It would act like a massive wrecking ball thrown through a delicate clockwork mechanism. A dynamic flyby shatters the perfect orbital balance that has kept our planet safe for the last 4.5 billion years. The first signs of its arrival would not be a sudden darkness. Long before the black hole reached the inner planets, its immense gravity would begin to pull at the outermost edges of our home. It would scatter the icy bodies of the Oort cloud and the Kuiper belt, sending a relentless bombardment of comets hurtling toward the sun. We would see the sky fill with falling ice before we ever felt the true gravitational pull. The universe is full of these wandering remnants, invisible and silent. They are the ultimate test of our fragile planetary order. And the deeper we look, the more we realize our safety is delicately balanced. We drift through the galaxy, and these unseen shadows never stop moving toward our neighborhood. To understand the escalating horror of a black hole encounter, we must start small. Very small. Imagine a primordial black hole, forged in the chaotic fraction of a second after the Big Bang. These theoretical objects could have the mass of a large asteroid, but be smaller than a single atom. What happens if one of these microscopic heavyweights passes directly through Earth? It doesn't swallow the planet. It moves too fast. Traveling at roughly 200 kilometers per second, it punches through the globe in less than a minute. As it moves, it acts like a supersonic jet, creating a shockwave of sound and pressure. It leaves behind a hollow, microscopic tube of thermal destruction through the mantle and crust. Modern sensors would detect this as a magnitude 4.0 earthquake. A strange global vibration that rings through the planet like a bell. But what if it passed through a person? The result is not an explosion. It is a quiet, biological unwinding. The black hole is so small that its gravitational gradient shifts dramatically over the distance of a single human cell. It pulls on one side of a molecule with vastly more force than the other. Molecular bonds tear. DNA strands shred. The tissue is mechanically obliterated by a microscopic shockwave, but primordial black holes are just the beginning. The real crisis starts when a stellar mass black hole approaches. These are the corpses of massive stars, weighing 5 to 100 times the mass of our Sun. If one of these wanders within 100 astronomical units of Earth, the danger is no longer just impact. The danger is orbital chaos. The intruder's gravity triggers a mathematical nightmare called the Kozai-Lidov mechanism. It violently stretches and tilts planetary orbits. Earth's perfectly balanced circular path becomes a chaotic ellipse. During one part of the year, our planet is dragged so close to the Sun that the oceans boil into the sky. Months later, we are flung out past the orbit of Neptune, freezing the atmosphere into solid sheets of ice. We are tossed between fire and absolute zero. And that is if we are lucky. Because there is a scenario where the gravitational slingshot effect simply snaps Earth's tether to the Sun entirely. The planet is ejected, cast out into the interstellar dark as a free-floating rogue world. The surface temperature plunges to absolute zero, and all life ends in the frozen silence of the void. And the black hole just keeps moving. It barely looks back at its victims. But what if the black hole comes closer? If a stellar mass black hole approaches within a single astronomical unit of Earth, the threat shifts from orbital chaos to physical dismemberment. The invader's immense gravity pulls on the near side of our planet much harder than the far side. This gravitational difference stretches Earth into an ellipsoid. The crust and the mantle decouple. Mechanical friction generates incomprehensible heat. Within seconds, tidal heating melts the planet from the inside out. The ground beneath your feet dissolves into a global magma ocean. Continents shatter. Volcanic fissures thousands of kilometers long erupt simultaneously. And then, Earth crosses a fatal threshold known as the Roche limit. This is the tidal disruption radius. At this distance, Earth's own gravity can no longer hold itself together against the black hole's pull. The planet spaghettifies. The globe stretches into a long, thin ribbon of superheated matter. Half of Earth's mass is flung outward into deep space as an asymmetric tail of debris. The remaining half spirals inward, caught in the black hole's fatal grip. As this material races toward the event horizon at nearly the speed of light, it smashes together, creating an accretion disk. The kinetic energy converts into staggering heat, reaching tens of millions of degrees. The black hole becomes a radiation weapon. It emits hard X-rays and extreme ultraviolet light, outshining the Sun by millions of times. Before the planet is completely consumed, this intense radiation strikes whatever is left of our atmosphere. Molecular oxygen and nitrogen ionize instantly. The entire atmosphere thermally expands and boils away into the vacuum of space, stripped entirely from the globe through a process called hydrodynamic escape. But perhaps the most terrifying part of this apocalypse is the visual spectacle. Black holes warp space and time. As the intruder aligns perfectly between Earth and the Sun, it acts like a cosmic magnifying glass. A perfectly dark circle appears in the sky, surrounded by a blindingly bright halo of bent starlight called an Einstein ring. This gravitational lensing focuses the Sun's radiation directly onto Earth's surface, amplifying the light to an unimaginable intensity. Oceans evaporate in an instant. The crust catches fire. The sky burns. It is an apocalyptic masterpiece, a beautiful, relativistic optical illusion that boils the planet alive. The very laws of physics that govern our universe become the instruments of our total destruction. Now, zoom out to the ultimate extreme. What happens if the intruder is not a stellar corpse, but a supermassive black hole? These are the galactic titans, weighing millions or even billions of times the mass of our Sun. Normally, they anchor the centers of galaxies, including our own Milky Way's Sagittarius A star. But sometimes, during violent galaxy mergers, gravitational recoil can rip a supermassive giant from its home and fling it into the interstellar dark. If one of these wandering titans approached the solar system, the rules of astrophysics would change dramatically. The scale is so immense that an incredibly strange paradox occurs. The event horizon of a supermassive black hole is vastly larger than its tidal disruption radius. This means Earth would not be stretched and spaghettified before crossing the threshold. It would pass through the event horizon entirely intact, swallowed whole by the void. But that does not mean we would survive the journey. Long before the event horizon even came into view, the gravitational chaos would obliterate us. As the giant approached from billions of kilometers away, it would drag the entire Oort cloud along with it. Trillions of asteroids and comets would rain down on the inner planets. Worse still, the supermassive black hole would be actively feeding. As it captured interstellar gas, dust, and rogue planets, it would build a gargantuan accretion disk and fire relativistic jets from its poles. These jets are beams of pure astrophysical destruction. They would vaporize the Sun and sterilize every planet in the solar system centuries before Earth ever reached the dark edge. But before you succumb to the existential dread, we must look at the mathematical probability of any of this actually happening. The universe is terrifyingly vast, but it is also incredibly empty. The statistical likelihood of a stellar mass black hole crossing paths with Earth is less than a fraction of a percent over the entire remaining lifespan of the Sun. For a supermassive black hole, the odds are virtually zero. The threat of an asteroid impact is astronomically greater than that of a rogue black hole passing through our solar system. What these scenarios really teach us is not fear, but profound cosmic awe. They reveal the sheer fragility of our existence. We live on a tiny rock, perfectly balanced in a gravitational dance that has allowed biology to flourish for billions of years. When we study these monsters, we look at the absolute edges of reality. We are so lucky to be alive.